Welcome to Chapter 3 of Introduction to Geography. Here we're going to discuss the human processes that shape world regions. We're going to start by talking about the two great revolutions that changed the world, at least on a human level. The agricultural revolution and the industrial revolution. To start with, what was humans like before, these two great revolutions? What were humans like before society started to gather? Humans are generally thought to be hunter-gatherer, meaning that they lived by foraging, hunting, and gathering their food up until about 10,000 years ago. Since they were hunter-gatherers, they stayed in small family-based groups, no major cities or anything like that. They wandered from place to place as nomads to take advantage of changing opportunities in the landscape. For example, this could be following large herds of animal, maybe moving towards warmer climate to gather berries, things of that nature. Because of this movement, they had a relatively limited impact on their natural environment. You don't necessarily find a lot of anthropological evidence and fossils from this time because they didn't really make a lot of stuff. They were an ecologically dominant species, however. They competed more successfully than other organisms for nutrition and other essentials of life, and exerted a greater influence than other species on their environment. For example, the Pleistocene overkill hypothesis says that early hunter-gatherer societies may have hunted certain species to extinction. Here we can see some rock art from Egypt's Sinai Peninsula depicting the hunting of ibex, for example, maybe the use of camels and horses. So, you have these hunter-gatherer societies that are around bowing and stabbing their meat at basically whenever they're hungry. But there's an issue there, wherein you can only do so much with that sort of lifestyle. Eventually, some societies, some groups, just determine that if I could keep animals in a location, I don't have to hunt them, easier to get my food, right? This domestication process eventually is thought to have brought about the agricultural revolution. So why are you going to shift from hunter to gatherer? Well, first of all, a change of climate. The ice age is receding at this point. This receding ice age provides more fertile land for crops to grow. Not only that, but the larger your population gets, the less reliant you can be on hunting your meal that day when you have to feed not just your family, but perhaps a village. Since you're not going to be going out hunting, following herds, you're going to abandon your nomadic lifestyle. You're going to shift from extensive land use to intensive land use. You're going to settle in small villages. You're going to have fixed dwellings. You're going to build houses, build businesses, things of that nature. Through dry farming, population densities could be 10 to 20 times higher than that of hunters and gatherers. Especially if you have irrigation from, let's say, the Tigris, Euphrates, and Nile rivers. This water bringing in, rising up, watering your crops for you, allows the crops to go a lot better. You can have your larger populations. Domestication of plants and animals proliferated at the expense of wild species naturally. This growth in food production enabled what we would, in modern times, call the birth of civilization. Complex culture of urban life characterized by writing, economic specialization, social stratification, and high population concentrations. What this means is you actually have cities. You have cities, which means you have employment. You have employment, which means you have employer and employee. And you have employer-employee doing one particular thing. Not everyone is going to either be killing the food or raising the child. You can have some separation between those. Several cultural hearths were thought to have merged between 8000 and 2500 BCE before the Common Era. These are located in China, Southeast Asia, the Indus River Valley, Egypt, West Africa, Mesoamerica, and the Andes. Notice locations here. We have some in Asia, some in the Middle East, and the Andes. Interesting. This expanding food surplus from this booming agricultural revolution raised the size of the human population on Earth's ecosystem that could be supported. In other words, the carry capacity was raised. Upon early plant-animal domestication, Earth's population was thought to be fewer than 5 million people, And of course, look at civilization today. We have over 7, approaching 8 billion people. That's 3 more digits added to that number. Very impressive. Here we can see a image of modern day irrigation along the Tigris River in Turkey. And this is modern, yes, but not a very different picture from what could have been going on in those early times, right? The river will provide your irrigation for you. The crops are probably a bit more organized in this picture than they were 6,000 BCE, but the point still remains. Civilization began to flourish on this exact river. The waters you're looking at in this picture were the waters that gave humanity the chance to be something more than just another one of the animals. Of course, lots happened between the advent of agriculture and farming, 8,000 BCE, and the Industrial Revolution, the advent of steam technology and machinery in 1750 Common Era. Lots of stuff happened. Civilizations rose and fell, right? You have a boom of different styles of art, for example. But in terms of the entire biosphere that is human, in terms of global impact, the Industrial Revolution was the next great big step forward. This is going from everything's hand labor to we can take the natural resources that are abundant to us and use them to benefit. The Industrial Revolution was based on technological breakthroughs made possible by, for example, Western Europe that had economic capital necessary for experimentation, innovation, and risk. Think of your great scientists of this era. And significant improvements in agricultural productivity in Europe. You've got greater population, greater amounts of people. Not everyone needs to be farming. People can use their talents in different ways. People can look at things scientifically. People can do experiments and still have food on their table for them to eat at the end of the day. Industrialization, colonization, and environmental change because of it, all very much intertwined. The age of discovery, around the 15th century, when European nations, mostly European nations, some other ones, but mostly European nations, started looking abroad for their resources, truly changed the world and shaped the world to what we have nowadays. They traveled throughout Spain, Portugal, Britain, all these various seafaring nations, traveled the world looking for silk, iron, gold, silver, things that they can use at their hometown, at their home countries. This exploration resulted in making colonies in the Americas, in the Indies, in Africa, in Southeast Asia, in India, places like that. And the world as it looks now is very much a result of this colonization in the 15th century. Not only politically, but also environmentally. Since 1750, total forested area on Earth has declined by more than 20%. 1/5 of the forested area on this planet is gone if you compare it to 300 years ago. Total cropland at that same time has grown by 500%. 5-fold increase. That's amazing. And energy consumption has 100-fold increase. So Europe, predominantly Europe, other countries, but predominantly Europe explored out looking for natural resources to help feed this industrial revolution machine that was happening. And the effects were vast. Let's just say that. As a direct result of colonization in the 1700s and earlier and later, you have a large disparity between wealthy and poor peoples and wealthy and poor countries. A have and have-nots, if you will. You can define countries today based on 3 terms: more developed, less developed, and newly industrialized. MDCs, LDCs, and NICs. You'll see those acronyms going forward, but just take half a second, stop, look at those phrases. What do you picture when you look at that phrase? You're probably picturing specific regions, specific people, and specific countries. You took a second, you stopped, you thought about these terms, and you thought about the people and the countries that they may represent. How does what you thought about in the last slide compare to what you're looking at with this picture? Notice the more green you get, the more wealthy you get. Green money, And the more brown you get, that's interesting, the poorer you get. The less wealthy you get, the haves and the have-nots. Think about colonization, think about the countries that traveled the world looking for resources and the countries that those were then taken over by, right? There's a very good correlation between these two things. Here is a list of common characteristics of more developed and less developed countries, based on what is more likely, what is higher, what is lower in general. And you'll notice most every good trait is high in a more developed country and low in a less developed country. More or less. Birth rate. We have low birth rates in more developed countries and high birth rates in less developed countries. Death rate. Low in more developed countries, high in less developed countries, right? Affecting population growth rate. More and less. Life expectancy. You live longer in a more developed country, you have a smaller family, and your family members are less likely to die. That's exclusive to more developed countries. The poorer your country gets, the shorter you're going to live, the more kids you're going to have, and the more those children are going to die. And of course, there are other things to look at: energy use, GDP, percentage of rural versus city life, things of that nature, literacy rates. A good way to look at this is, if it's something you like about your life, it exists in a more developed country. If it's something you don't like, it exists in a lower developed country. So how exactly are we terming more developed and less developed, right? Is it just purely based on wealth? Is it based on life expectancy? In reality, it is a combination of all these metrics. Well, there is no universally accepted standard for measuring wealth and poverty on a global scale. You can have a very good estimate of this based on some of these common indices, such as gross domestic product. That's a phrase you've probably heard before. That is the total output of goods and services that a country produces for home use in a year. Gross being before use, domestic, and home, product, right? You also could look at your gross national product. That is, including with the gross domestic product, foreign output by domestically owned producers. It's not only what the house is using, but also what they're selling to other people. Use these two, and you can also infer a gross national income. That includes GDP plus income from abroad from sources such as rents, profits, and labors. So, more or less what the country is doing economically as a whole, not just in terms of the household or in terms of sales out. You can look at purchase power parity. Consider differences in relative prices of goods and services, and measure the currency in international dollars. What is my money worth in my country compared to other countries? If you've visited a foreign country with a different currency than your own, you know sometimes your $1 buys you more or less, right? And finally, you can look at Human Development Index, which is a estimation of scales that consider attributes of quality of life. This would be your life expectancy, your death expectancy, your people living in urban versus people living in rural environments, things of that nature. Here we have a list of the top and bottom countries per capita gross national index and purchase power parity. That is, according to US dollars, how much does the country have to spend and what is its money worth? And if we look to the left here, Luxembourg, Norway, Switzerland, Denmark, Austria, Sweden, all European countries dominating the upper end. You do have some outliers. Singapore, very wealthy, but there's special reasons for that. The United States, you probably expected that to be at the top, right? Australia, doing very well. And then when you look at the bottom list, again, you see a abundance of a certain part of the world. Togo, Sierra Leone, Malawi, Niger, Eritrea, places like that, the Congo, Dominican Republic. These are African countries. Burundi, very, very poor African countries. Afghanistan is, of course, in the Middle East, places like that. Right? And then what you need to care about more, well, I'm sorry, not what you need to care about more, what I want you to look at more than just base location and maybe image of person is the actual number sitting here. Per capita for the lower countries are in the hundreds. Per capita in the upper countries are in the tens of thousands. Think about, a person has $300 to spend versus a person having $38,000 to spend. That goes well beyond just a little disparity of rich and poor, the boss versus the employee levels here, right? That is ridiculous difference in money. $38,000 for the lowest end of the top countries versus $800 for the highest end of the lowest countries. Take a second, soak that in. So we see this very large difference in quality of life and monetary assets between these two countries. Well, why is that? Why are some countries rich and others so desperately poor? You could argue there's a dependence theory association with this, right? Worldwide economic patterns established by the Industrial Revolution and colonialism persist into today. It shouldn't be surprising that the colonial powers are at the top of the list and the colonies are at the bottom of the list. Yes, America, I guess, would be the exception to this rule, but America became a colonial power in a sense at the midpoint of its life, and then post-colonialism, America exploded for reasons we'll get into. You could argue there's advantageous and disadvantageous locations for wealth and growth. A lot of the countries we said are in Africa. Maybe Africa's not a good place for wealth to grow, although that kind of argues with dependence theory, the first thing we covered, because if wealth doesn't grow well in these African countries, why did Europe go to these African countries to gain wealth, right? There's cultural and historical factors you could argue, although that again is tricky because power throughout the world has shifted so many times that it's kind of hard to link a cultural factor to current or past or future wealth. But it is an avenue worth discussing. Of course, we shouldn't just talk about the human impact of less developed, underdeveloped countries, but also some environmental impacts as well, right? Less developed countries usually have to borrow money from more developed countries to fund development. This is a big thing going on right now in Africa. China is giving lots and lots and lots and lots and lots of loans to African countries to build infrastructure. Well, if you borrow money from someone, maybe they're going to want something in return later, right? It's a question you need to ask. Many of these lower developed countries are unable to pay the interest on these loans. If you can't pay the interest on it, you're not paying off principal, you keep in debt, right? When lender institutes threaten to cut off assistance, borrowing countries often try to raise money quickly using various not as good methods, such as a dedication of high quality land to production of cash crops, which are then exported to wealthier nations as luxury items. A cash crop is not something you eat. That's the big deal here. You look at, again, I'm going to go to rural Africa for this. You look at farmers in Africa, they're not eating the food they're growing. They are having problems supplying their family with nutrition and food because everything they make has to be sold so that someone else in their country can make a lot of money selling it to China or America or Europe, things of that nature. And of course, the sale of natural assets, right? Mining, oil, these things come into mind. These methods of quick money raising have a drastic long-term effect on the environment. Humans using resources faster than nature can replace it. Cash crop farming soaks up all the nutrients in the soil that allows plants to grow, so when you do, at the end of your season, try to plant a little bit of food, it doesn't grow as well. And of course, there's an ecological bankruptcy associated with this. This occurs when the countries exhaust even their environmental capital. If you have nothing left to give, but your debtor still wants their money, what exactly are you supposed to do? Keep in mind what I've been talking about the past couple slides and take a look at this picture of a river in Vietnam. Look what these people are wearing, look what these people are doing. They appear to be washing their dishes in water that I don't even want to look at. Right? This is a result, and Vietnam actually, in the past couple years, even since the slideshow, has been growing, developing at a pretty good rate. But there are people that have to wash their dishes, living right now, washing their dishes at this very moment in water that I don't even think I'd want to look at. That tells you something about the quality of life they have. So let's get into the geography of population. The study of population is called demography. Population may be the most critical issue in geography. Welfare of humanity and Earth's other species' natural habitats is tied directly to the number of people and the rate at which those people consume natural resources. The human population has been absolutely exploding since 1800. The question is, if people and the amount of resources people consume are directly related, you have a vast increase in the amount of people. Those people going to consume things. If you want to keep the general balance the same, either you need less people or you need people to consume less resources, right? And of course, beyond this general population explosion, you also have migration issues. You have people moving from one area to another. These people, when they come, these people, when they leave, they spread culture, ideas, and opportunities, but they can also spark tension and violence. As of the making of this slideshow, and as of the making of this YouTube video, this is a hot button topic throughout the world. So, exactly how many people do live on the Earth? Well, it is thought that the Homo sapien ancestor came out of Africa around 100,000 years ago. And then by about 1800, there was an estimated population of 1 billion. So from these early, very, very small, maybe population of 1,000 sized Homo sapien ancestors 100,000 years ago to 1800, there is 1 billion people in that spread. And then from 1800 to 1999, 5 billion more people were added. That chart just goes straight into the roof. Humans are now by far the most populous large mammal on Earth. Nothing else really comes close. 1, because we're growing so fast. 2, because we're killing the other ones off. This chart, again, is kind of ridiculous. It basically flatlines at not a whole lot of people for 2 to 5 million years ago to about 2000 BC. Then it slowly starts to climb, takes a little dip at the Black Plague, at the Black Death, the plague, excuse me, and then just jumps, just goes straight up. It's almost asymptotic in the way it grows. And what's going to happen in the next 100 years? How exactly high is the population going to get? So how do these numbers come about, right? How do they measure the population changes? Someone didn't just walk around and duck, goose every single person that's living at any given moment. You find these population sizes by looking at, for example, birth rate, or the annual number of live births per 1,000 people in a population. Perhaps death rate, the annual number of the annual number of deaths per 1,000 people in the population. Compare these two, and you get a general population change rate. Either a growth or a loss, depending on what's higher, people being born or people dying. We know more developed countries tend to have smaller families and less developed countries tend to have larger families. Well, why is that? Well, it appears that better educated and wealthier people that understand the economic cost of raising and educating a child tend to have fewer children. Contrarily, less educated or poorer people generally have more children, sometimes to have additional workers, for example, to bring in more family income. People in cities tend to have fewer children than rural areas, and again, if your country tends to be more rural than urban, therefore you're going to tend to have larger families, right? More kids to work the fields to help bring in more product. Those rural families also tend to marry earlier, thereby giving you more children. Couples with access to understanding of contraception naturally have fewer children, and there are also value systems and cultural norms that play into family size. And these things all interconnect, right? Better education and more wealthy, maybe more access to contraception, less need for children to help bolster your own wealth, therefore less children. Therefore, more money spent on each individual child. Less wealth to begin with, children need to supplement your income. You can give out these children when they're old enough, with the growing up under the assumption that I need many children in order to provide for my family. Those kids have more kids. This stuff all interconnects, giving you large families for low income and small families for large income. We talked birth rate, or family rate. Now let's talk death rate. Death rate, as you would imagine, correlates mostly towards health factors. The healthier society is, the older people live and the less people die in each particular year. Things that can actively affect death rate include sanitation, hygiene, access to drinking water, medicine availability such as antibiotics, immunization, insecticides, and in general improvements to the medical and public health care sector. Death rates, of course, will rise with epidemics such as HIV/AIDS, Black Death, the coronavirus that we're in the middle of now as of the recording of this video. And, well, life expectancy plays a role as well. Life expectancy is directly related to the medical care you have as an elderly person. If you get an injury of some sort, the chances of you bleeding out in a hospital is far less severe than the chance of you bleeding out at your house, right? You get a infection as an elderly person, you're more likely to survive given better access to medicine and better access to a general well-made healthcare sector. You live longer. Therefore, death rate goes down. Here we see a map of life expectancy throughout the world. And again, when you look at this map, as with every map we're going to look at throughout the entirety of this course, look back and think about maps you've seen of related topics, right? Where is life expectancy high? Where is life expectancy low? And what other factors, geographic factors, both climate, bio, as well as human factors, also high and low in these particular parts. So we've talked about family size, birth rate, we've talked about death rate. What determines the population change rate as a whole? Well, first of all, you have to take into account things such as natural disasters, diseases, and wars. Things that are not on a individual level, but rather on a entire civilization or large community level. Secondly, you have to look at the fact that birth rates are higher than death rates. So you have a trend of growth, right? This idea of growth and increasing amount of increasing growth leads to a statistical idea of doubling time, meaning the number of years required for a population, in this case human population, to double. You get an approximate doubling time by taking 70 and dividing it into whatever growth rate you have. Meaning, as of 2011, for example, with a population growth rate of 1.2%, every 58 years you should expect the population to double. In 2011, I think the population is around 6 billion. So 58 years into the future, in 2069, for example, you should have a population of double 6 billion, 12 billion. This map is interesting when related to the last map because the locations have the same color scheme, but now the purpose of the color scheme has been inverted. Because in general, it is perceived that less developed countries have higher growth rates because of unnecessarily large families unnecessarily compared to what we in the more developed countries would see as required. So the brown colors, the red colors, the shading that's predominantly in Africa, that is large rate of natural population increase, but that's also considered a detrimental thing, as opposed to America's, Europe's, Russia, which have level or maybe slightly increased population levels, which is generally considered a trend of a more developed country. If you think about the course of human history, in modern times, populations have exploded in size. Well, why is that? If the birth rate is high and death rate is low, you naturally have a surge in population, right? This scenario has been encouraged since 1800 or the advent of modern medicine. These demographic transition models from pre-industrial, transitional, industrial, and post-industrial pervade a what is my society doing to make money and what is my society doing to heal its wounded and sick. And we notice that even though that birth rates may not necessarily be as high, smaller families in essence, death rates are kept so low and people are living so much longer that populations increase almost at an exponential level. Here is a visual of the demographic transition model I was talking about previously, where you have birth rate and death rate working with each other in such a way that pre-industrial, you have high birth rates but also high death rates and low life expectancy. As you transition towards less manual labor being required for the population to gain money, as well as better medicine to deal with stuff, death rate precipitously decreases off, while birth rate remains more or less constant. Eventually, civilization gets to the point where birth and large family is not necessarily required, and birth rate eventually comes down, and has shown here in a post-industrial society, you have very low amounts of death, unnecessary death, very low childbirth death, for example, and low population sizes, which have a stabilization effect that happens. Post-industrial society would be a more modern developed country, right? Transitional is more or less what the lesser developed countries, you could argue, are in now. So now that we have an understanding of birth rates, or family size, death rates, and population change, let's discuss an age structure diagram. More specifically, let's talk about a population pyramid. This is a way to understand how a society is functioning, how society is growing, and what society is going to have happen to it in the future. They are classified populations by gender and by 5-year age increments. And you will notice a trend with less developed and more developed countries. Less developed countries are very bottom-heavy in pyramid shape, indicating a large youth population that dies out essentially as it gets older. The population shrinks in. Whereas more developed countries have chimney-shaped, so you don't have necessarily a lot more youth than adults than elderly, and the adults live to be elderly to again increase those populations, right? Here again are 3 examples. Niger, a poor country, a less developed country with a relatively high birth rate, has at the very bottom of this pyramid the very widest breadth. The majority of the population in this country is very young, and as you get older, you're less likely to survive, so the upper part of this pyramid is thinner, and the pyramid in general is shorter. Contrast that with the United States, where the block from the youngest to relatively old, we're hitting about high 50s, early 60s, is basically the same shape. The amount of people you have at 4 and the amount of people you have at 44 are equal because the family sizes are smaller and those people are living longer. Move to someplace like Germany, you can see that the majority of the population is older and the younger population isn't of the same size. So as this graph continues to trend up, the larger population will die out and there won't be enough of the younger population to sustain the numbers that they have currently. So the graph and essentially will keep a shape but will shrink in. The point of that was to show that less developed countries and more developed countries have family sizes and family structures that correlate with other things we've talked about, such as availability of income, availability of healthcare, things of that nature. You look at a less developed country's population, it's going to have a particular shape to it for this graph as opposed to a more developed country. So we talked about how we live, how we die. Well, where do we live would be a next question, right? What we find is that natural setting is a very important factor to determining population sizes. China and India are the most populous countries in the world. They have each over 1 billion people. Around a third of the people that live on Earth are either Chinese or Indian. It is remarkable the amount of population that exists in just those two countries. The United States is the third most populated country in the world, but the amount of people that live in the United States compared to China and India is a staggering difference. I think there's around 300 million, maybe 400 million around there in the U.S., and we're the third most populated. And then you literally add 1 billion people to that number to hit the second and first most populated countries. And now we can talk everyone's favorite map, the cartogram, here proportionalized to population, showing just the ridiculous amount of population China and India have. Also, pointing out noteworthy other large populations you may not think about, such as, in this case, Brazil and Indonesia. Very large populations, Pakistan, very large population, but when compared to, again, China and India, everything just falls on its face. Aside from just rote numbers, we can also talk population density, or persons per square unit of measure, kilometer or mile. And again, we notice, first of all, China and India, very densely populated. But, noteworthy here, only the east part of China is heavily populated. Western China, essentially the Himalayan mountains, nothing. That's an interesting thing. China has a very large amount of land, but the amount of land that's lived in is very small by comparison. And then you can also go look at the U.S. and look at the population densities there. That is more sparse city spots than anything else, right? India is basically all densely populated. The U.S., not. Brazil, not. Interesting things to think about. And then, of course, Europe would also be, and Central Africa, right there on the western part of Central Africa, somewhat dense parts of population. An important factor to take into account when talking about population is migration, or moving from one country or place or community to another. You emigrate out of a country and immigrate into a country. Migration is driven by various push-pull factors. Pushing you out of one country, for example, a lack of land, hunger, warfare, natural disasters may push you out of a country, and then opportunities, jobs, education, family may pull you into another. Here we can see global migration trends, again as of 2012, 2013, when this slideshow was created, showing what we'd expect trend, meaning more developed countries people tend to go to, less developed countries people tend to flee from. Of course, in the U.S., we have the United States-Mexico border as a hot-button issue for immigration, and we can see very high immigration counts in Mexico and Central America, and very high immigration counts in the United States and Canada. But that's not just a local trend. Throughout the world, people are leaving or coming to various countries. So we talk about people moving, people being born, people dying. How many people will live on Earth in total? Interesting question. Although it has been possible to calculate how many people have lived on the Earth in the past with some confidence, projecting future numbers, of course, has its difficulty. What will happen to birth rates? As places develop, birth rates tend to go down. Is the world going to keep developing forward, and therefore is birth rates going to continue to fall? Likewise, death rates can change dramatically. You have a strong disease or epidemic happens, you have a large war happens, death rates rise significantly, right? The United Nations does its best to estimate and predict these things, with a prediction of about 9.3 billion people by 2050. The maximum number of people that will ever live on the Earth at one time is expected to be about 10 billion by 2100. This is the United Nations prediction. Who knows what's going to actually happen? Certain countries, such as this example in Egypt, and of course most widely known China, have promoted family planning as a way to circumnavigate and alleviate some of the issues of population growth. This is, of course, a hot button issue with access to contraception, abortion, all being enveloped in this conversation. So what is the population going to look like? Are we going to have a high trend, as shown by the green markers, a medium trend, sort of a logilistic trend, shown by the yellow markers, or perhaps a low trend, shown by the purple and red markers? These predictions are merely predictions and projections, but this information is useful for governments and for charitable organizations to try to have a grasp of what needs may arise in the future. So let's talk some population trend scenarios and theories. The Malthusian scenario, named after, of course, the oldest man in the Bible, Methuselah, it was a scenario concocted by Thomas Malthus, an English clergyman who lived during the Industrial Revolution. He postulates that human population, growing geometrically or exponentially, will eventually exceed food supplies, which of course would grow arithmetically or linearly as a line, and predicts a catastrophic human die-off as a result of this irreconcilable question. So essentially, we're going to outgrow our food because food will never be able to keep up with us. Neo-Malthusians insist that birth rates must be brought down for humans to avoid this catastrophe, right? If humans are always going to grow and multiply exponentially, crops aren't going to keep up, humans shouldn't be growing and multiplying exponentially. That way crops will keep up. A technocentrist approach to this, of course, is that we can produce better crops which can grow faster and keep up with human population growth. Which of these two is more likely to come about? Well, that's what the predictions are about, right? That's why we have these conversations now. Are we going to hit a point of crisis, as shown in this map, where the population is going to not have enough food for itself? Or will resource totals be able to keep with population trends and continue to grow alongside them, as the technocentric, according to Cengage, argument and view states? So we talk a lot about population and issues that can come from overpopulation. What do we mean by overpopulation? Overpopulation we're going to consider in two different ways: people and consumption. People overpopulation, characterized by those lesser developed countries, is lots and lots of people living on, individually, not a lot of stuff. So you have a lot of people not consuming a lot of stuff individually, but in total consuming, again, a lot of materials and resources. Cross that with consumption overpopulation, characterized by more developed countries, where a few people consume a lot of stuff. Small numbers, lots of goods, still using lots of goods in the end. Both of these overpopulation examples have the same result, wherein lots of natural resources are consumed. It's just, do you have a lot of people consuming little, or little people consuming a lot? Here we have some rather stark visuals to explain this process, with the notably not white developing poor people and the notably white waspy developed people utilizing different consumptions per people and having different technological impacts per unit of consumption to produce, in the end, bad things, whether it be starving children or some Wall-E looking car wrecks for a landscape thing going on. Point is, these are both resulting in bad environmental impact. You don't want to have to choose between these two choices. You ideally would want to create an environment where you do not end up with starving skeleton-faced children and piles of busted-up cars littering the world. Well, how are we going to deal with this? Well, since birth rate and death rate are the primary factors leading towards these issues, we can either deal with, the argument that is being made here is, we can either deal with the death rate, or we can deal with the birth rate. The death rate solution, or the light both ethics argument, is to let nature take its course. Sure, people are going to die, but that's going to lower the population, right? This idea was first introduced by ecologist Garrett Hardin, and he argues instead of seeing the Earth as a global village with a single carry capacity, he views the world as a distinct number of district lifeboats occupied by citizens of those countries. Wealthy nations, the lifeboat has comfortable seating for a few. Poor nations, the lifeboat is overcrowded and some people fall off, right? Well, the occupants of the rich lifeboat can choose to take on the overboard refugees if they want to. Hardin suggests not, instead preserving their own standard of living and ensuring the world's safety for themselves and future generations. This is, in essence, the dystopian future version of what can happen, wherein those wealthy elite can live in their ivory towers and the rest of the poor people that didn't manage to pick themselves up by their bootstraps, or some ridiculous idiom, just have to suffer and die because, well, that's just the way things go. Sucks to be you. The argument being made is signifying this picture somewhat. Sure, this doesn't look comfortable, but, well, that's just the game you played and I guess you lost it. That sucks. Fall off your lifeboat and die. I like my leather chairs. Of course, the solution to the future overpopulation question does not have to be as bleak as was stated. You could instead look at birth rate solution and sustainable development as a cure. People must, in essence, this argues that people must change their worldviews and value systems and recognize the fact that the Earth does have finite resources and reduce expectations to level sustainability by Earth's capabilities. People should recognize that development and environmental protection can be compatible. Meaning, you should think about what's going to happen in the future when you do what you do today. Communities and countries can strive for self-reliance, particularly through the use of appropriate technologies. Less developed countries should work on limiting population growth as a means of avoiding destructive impacts on people's overpopulations. Governments should practice land reform, again, notice here, particularly in lower developed countries, and economic growth in more developed countries should be slow to reduce the effects of consumption over population. Meaning, a wealth redistribution, in essence. Hot button issue, yes. This book, this course, well, I'm not going to say this course, this book kind of gives you two stock choices here. The lifeboat ethics shows essentially poor black people starving in a boat, and I'm saying, well, you can either have poor black people starve in a boat, or maybe you don't need that fifth house. And that is quite an oversimplification of the question, of course, but these are two ways of looking at the problem, and God's honest truth, it's a problem that needs to be looked at. We're going to talk further in this class, go into the different regions of the world, discuss kind of what the world looks like now, what the world could look like in the future, things of that nature, why these things are the way they are. And we want to keep Chapter 3's arguments and ideas in our heads as we look around and travel throughout the world. Thank you for listening in. Please leave any comments and questions down below. I'll get to them as I can. And enjoy the rest of the class.